Hello, Justin. Welcome on Gelato on the podcast, and nice to have you here.
Hey, thanks for having me, Luis.
So yeah, first of all, thank you very much for coming on. It's a great honor to have you here. Long-time follower of yours. Must have been like seven or more years that I've listened to your voice on various podcasts. So it's an honor to be the host today. And we will go very deep on all of the topics that are that you've recently proposed in the last, let me say, 1 to 1.5 years. Like the combination of based rollups, native rollups, I think that's the more recent one, and also Beamchain, which you presented at, I think in Bangkok it was, and at DevCon. So I think we can roughly start with you giving, an outline of all of these very technical topics, how they fit together, how you organize yourself around them, like where are you gonna spend your time on, where are you building teams, what's the future sort of execution path for these. So you can really spend a lot of time talking about this, and then I will ask you some questions about it. We can go deep on each of these topics, I think with maybe a bit of a special focus on native rollups, because we just wrote a blog post on them on the Gelato side, which actually was quite well received. And then we can talk about Ethereum's future in general. I know that you are very, very bullish on synchronous composability. I've had my ups and downs with that thought experiments. So happy to pick your brain on that. And then in the second part, we can talk a bit about the broader market dynamics, how Ethereum L2s look today, how they will look in the future, what's working well, what's not so working well, right? But let's start with the tech. So please let us know, what are these big projects that you're working on? I know Beamchain is sort of the one that you're most dedicated to yourself, but what about base rollups? What about native rollups? And what about ZK? Let's start with that.
Okay, wow, what an agenda. So I guess a lot of my research, quite plainly, is just trying to improve Ethereum. And I guess we can split the topics into 2 parts. One is improving the L1, where we have the Beamchain and the Beamchain, yes, and more recently this effort to scale the L1 gas with ZK EVM, something that I'm spending a lot of time on and something that I'm very excited about. And then at L2, there's this idea of, as you said, the base rollups and native rollups. So I'd say most of last year in 2024, I focused on the L2, and now in 2025, I'm going back to the L1. So let me start with the work that I did in 2024. What I tried to do basically is solve 2 of the biggest problems that I see with L2s. The first one is that L2s today, as they have developed, have broken the network effects of Ethereum. So traditionally, the more applications we have, the more users we have, the more network effects we have, because we have these money Legos, which are composable with other money Legos. And we also have network effects with moneyness, because Ether itself is a money Lego. And these things have started to break down, because each L2, in many ways, is a silo. So it is reusing the L1 for settlement. And that means that you have access to a lot of assets, but you've lost this idea of synchronous composability, as you mentioned. And so I spent some time thinking about how to achieve synchronous composability again. And there's basically 2 ingredients that we need. The first one is shared sequencing, and the second one is real-time proving. And real-time proving, I've always had this conviction that we'll get there eventually. It's just technology, it's just engineering, and this is something that humanity is very, very good at. But on the other hand, shared sequencing is much more of a social coordination problem, because we need humans, specifically like governances, to somehow agree for the L2 to opt into a shared sequencing mechanism. And there's some competitive dynamics here. If someone builds a sequencer, will a competitive L2 want to opt in? Maybe not. And there's also incentive alignment issues around maximizing income for the various L2s. And so the conclusion that I had was that in order to achieve shared sequencing, we need a credibly neutral sequencer. Otherwise, we're just never going to get there. We're not going to agree. We need basically the strong shelling point. And I looked around, and the only credibly neutral sequencer that I could find is Ethereum itself, right? Because Ethereum itself does not introduce a new token, a new brand, or a new security assumption. I started thinking, okay, how can we make the L1 sequencer, the so-called based sequencer, because it's the one that's present at the base layer, so attractive that all of the L2s will want to opt into it. And the main downside that I identified was around preconfirmations. So this is where I spent a bunch of time thinking about how can we dramatically improve the UX of the base sequencer, which unfortunately inherits these very long slots, 12-second slots. As I mentioned, in 2025, I kind of put out a bunch of research and did a bunch of coordination to get these preconfirmations out. And the idea of preconfirmations is very simple. It's that you have an entity called the sequencer or the proposer that has monopoly power over a full slot, 12 seconds. And the users, what they'll do is that they'll talk to the sequencer or proposer directly, who will issue promises about which transactions they will include at the end of the slots when they produce the block. And it turns out that these promises can provide excellent UX, because not only are there inclusion promises, but they're so-called execution preconfirmations, where if you're making a trade, for example, a Uniswap, you know exactly what price you're getting and how much you're paying in fees. And we went through this whole research cycle, and ultimately we landed on constructions that are pretty simple and that today are being built out. So, for example, there's this team called Fabric. The Ethereum Foundation gave a grant to them, and I think they're doing a lot of great work to try and standardize all of the pieces of infrastructure that we need in order to enable preconfirmations. And my hope is that once we have unlocked this missing piece, the preconfirmations, base sequencing will become extremely attractive, and then we can hope that slowly over time, more and more L2s opt into it, and we regain this synchronous composability. So that's problem number one at L2. Problem number two within the L2s that I identified was around security. This idea that a lot of the L2s today have massive security gaps. So one of them is that they all have, more likely than not, bugs in their implementation. So if you want to build an EVM equivalent L2, you basically have two options. One is to build a fraud-proof game, if you're an optimistic rollup, or to build a snark circuit if you're a ZK rollup. And both of these things are extremely complicated to build. Basically, what you're doing is that you're emulating the EVM within the EVM. You're re-implementing the EVM, and you have all of these constraints of the fraud-proof game or the snark circuit. And so my claim is that every single fraud-proof game and every single ZK circuit that's in production today has critical vulnerabilities. So that's problem number one. Problem number two is that in order to fix or mitigate these vulnerabilities, they introduced another vulnerability, which is the concept of a security council, which is basically just a multi-sig, which most of the time in practice will make things better, because it means that you can make these fast changes. But from a first principle standpoint, it's kind of very centralizing and itself a security vector that can be taken over. I've been part of various security councils, and I think it's actually relatively easy to take over a security council, in the sense that you can do a bunch of social engineering, where usually what happens, at least that's how it was done in the past, is that you have some sort of a team lead of an L2 that says, hey, please sign this message, and it's in the Telegram group. And people will just say, hey, I've signed it. And there's very little due diligence that is done. And recently we saw the hack of an exchange. They lost $1.5 billion, I believe, through some sort of social engineering around a multisig. And I wouldn't be surprised if we see something similar for an L2. And recently I made a commitment that I wouldn't be joining any more Security Councils, and I've been winding down slowly all of the Security Council engagements that I've had. And then the third issue, in addition to just bugs and the Security Council, is governance. So fundamentally, if you have an EVM equivalent rollup, it needs to stay in sync with the L1, which is itself an evolving beast, right? The L1 EVM, every hard fork changes. There's EIPs that change the rules of the EVM. And so if you want to stay in sync, you need to have a way to modify your L2 over time, and that's called governance. And governance can be slower moving than a Security Council. So for example, it could be on a multi-month cadence as opposed to being able to make changes immediately. But that's still, in and of itself, an attack vector that we'd like to remove. And so the new idea here, which is the native rollups, is what if the L1 could share its execution layer, so what's called the EVM state transition function, with the other L2s. So you can think of the L2s being able to inherit an exact copy of the L1 EVM. And so that, in some sense, is trying to solve all three security problems. It means that you don't have to re-implement the EVM within the EVM. So instead of emulation, you have what's called introspection, which is that the EVM can basically enjoy a copy of itself within itself without having to re-implement it through this precompile called the execute precompile. And by construction, it's enforced in the exact same way that the validators secure the L1 EVM. So by construction, it's bug-free. And so it means that you don't need a Security Council. And also, by construction, because it's an exact copy of the L1, it evolves with the L1. So you don't need governance to stay in sync. And kind of as a nice cherry on top, it turns out there's some synergies between the idea of base rollups and native rollups. So when you have multiple native rollups that all share a sequencer, whether or not it's based, the real-time proving aspect becomes much simpler, because the L1 has basically this kind of superpower that it has the ability to do what's called delayed execution. So delayed execution is this idea that the state root is kind of posted with one slot delay. And this is something that you can't do with normal L2s. You can only really do that with native rollups. And because you have this extra one slot, you have more time to do the proving. So there's two types of real-time proving. There's like hardcore real-time proving, where you need to do the proving within maybe 100 milliseconds or a few milliseconds. And then there's next slot real-time proving, where you have a full slot, the full 12 seconds. And that is something that we've achieved actually today. So we have this second ingredient, and once we have native rollups that share a sequencer, then you can have this simpler form of synchronous composability. So that's the work on the L2s. On the L1, basically there's been a couple of things that I've been trying to push forward. The first one is, how can we make big, ambitious changes to the L1? Because traditionally, the status quo has been to do small incremental changes. So we have a de facto design, and we try and improve it at the margins. And the way that we do that is that every year we have some hard forks, and we have a collection of EIPs, for example, 10 EIPs, and each EIP will kind of nibble at the frontier to try and improve the status quo. And because we're so conservative, and so, what we end up doing is basically trying to minimize the diff between the status quo and the change. And so the way that we think about upgrades is in the context of the status quo, of the de facto design. And this way of thinking basically prevents us to think from first principles, right? What if we had a clean slate? What if we were not encumbered by all of the technical debt that we have? And essentially, this is what the Beamchain is all about, is basically opening the overturn window and putting forward as a possibility to think from first principles as opposed to thinking from the status quo. And my personal belief is that if we do think from first principles, we have at least a 10x opportunity in front of us. We can have an L1, which is 10 times more secure, 10 times simpler, and just generally has much less technical debt and is future-proof. And there's this meme of ossification, right, which we all kind of appreciate in our space, especially through Bitcoin, right? Bitcoiners love this idea of ossification, but the Bitcoiners have achieved ossification through just being extremely stubborn in some sense, just saying we're going to ossify for the sake of ossification. But I don't think that's sustainable. And I've been quite vocal about the fact that, in my opinion, the security budget issue with Bitcoin, with the issuance decaying exponentially, is going to eventually bite Bitcoin and may lead to its demise. And so ultimately, ossification and the 21 million limit, which are two of the key strengths of Bitcoin, may ultimately lead to its demise. And so what I would much rather see in Ethereum is this notion of ossification through optimality, right? A design which is very, very close enough to being optimal so that the opportunity to improve it is very, very small, and we don't need to improve it. We can just leave it be. The cool thing is that as blockchain research has evolved over time, we have what I call lower bounds. So we can prove that within our design space, certain things are possible and some things are not possible. And the things that are not possible are called lower bounds. And the things that are possible are called upper bounds. And what's happening is that the delta between the lower bound and the upper bound is shrinking and shrinking. And basically, we're getting closer and closer to optimal design. So, for example, in the context of post-quantum signatures, specifically hash-based post-quantum signatures, we now know that in order to make a hash-based signature, you need at least 2.5 kilobytes. And we have constructions that are 2.5 kilobytes. And so we basically have an optimal post-quantum hash-based signature. In the context of consensus, right, there's certain impossibility results that limit our design space, and we have designs that basically achieve what is within the realm of what's possible. And some of the key things that basically the Beamchain is trying to do is make the L1 as robust and durable as possible, as hard as possible, and that includes making it post-quantum secure. It also includes making the validator set as decentralized as possible with things like Attester-Proposer Separation. So making sure that as a validator, you don't have to be sophisticated. You don't have to worry about MEV spikes, relays, preconfirmations. All of that stuff is kind of pushed to more sophisticated entities. And kind of a similar thing is this idea that as a validator, you shouldn't need a fancy internet connection or fancy hardware. You should be able to use a Raspberry Pi or some sort of embedded device on your phone or whatever to stake, and similarly, you don't need a fancy internet connection. Now, that's the Beamchain, which is all about security and hardness. And then the dual concept, I guess, is scaling. Like, how do we have as much throughput as possible on the L1? And here there's two ways to scale. So we can scale the L1 gas, or we can scale the blobs. I haven't been spending much time on the blobs but more recently I have been spending time on the L1 gas. And the idea here is pretty simple, is that instead of the validators having to re-execute L1 blocks, they just have to verify snark proofs. And these snark proofs are constant size and constant time to verify. They just take a few milliseconds to verify, and downloading the proof is very small and constant size. So you can imagine basically removing the gas limit, having an arbitrary large blocks, and that not mattering to the validators, because the amount of work that I have to do is constant and doesn't matter what the gas limit is. And I have this kind of meme / vision, which is that we should be able to achieve 1 gigagas per second, which is about 1,000 times more than what we have. And part of the reason is that once we remove this primary bottleneck of the validators having to re-execute blocks, all of the other bottlenecks should be similarly removable with actually much less fancy technology, just with traditional engineering, not with this fancy real-time ZKVMs. Sorry, I've been rambling a lot. Let me give you an opportunity to ask questions.
No, that was great, and I specifically asked for you to take your time. So it is quite a lot of background there, and we will unpack some of these pieces one by one, slowly as we progress through this podcast. Especially, we're gonna double-click on native rollups. We're gonna double-click on sequencing-based rollups, the idea of synchronous composability between rollups, but especially also between rollups and the L1. And we will also go a bit more into the Beamchain. You just ended your intro there with saying that you didn't focus so much on the blobs recently, which is like essentially the main throughput bandwidth scaling factor for L2s on top of Ethereum, I suppose. And you focused a bit more on L1 gas. I myself, I'm still very bullish on rollups, L2s. And I know recently Ethereum has been a bit in a tough spot because Ethereum is fighting a war on multiple fronts. On the one end, you have Ethereum's past, that's sort of Solana, that are sort of optimizing for just an L1 that is super high throughput and execution, everything happens on the L1. And there has been some voices in the Ethereum camp trying to compete more on that front again. On the other hand, of course, Ethereum is already on the rollup-centric roadmap, and there's a lot to do there. Like most of the things that you touched upon actually are in service of the rollup-centric roadmap, I would say. I personally am still very bought into the rollup-centric roadmap. I myself think if Solana brands itself as decentralized Nasdaq, that to me sounds like an application that should sit on top of Ethereum at some point and not be its own sort of just layer one. But yeah, so where do you currently in the sort of tug of war? It definitely sounds like you're dedicating most of your time and thinking with high conviction to the rollup-centric roadmap, not getting spooked by a couple of sort of insecurities that are currently there. But this so from your perspective, what should the L1 do in the future, and why is it important to still improve the L1 a lot in terms of gas and not just blobs, for example? Or is it just an interim feature to keep users happy, which is also a good strategy, right? Like it will take time to execute on the rollup-centric roadmap. Like let's have a sort of interim smoothing phase where the L1, which is where I have my money, where many users have their money, let's still make that a bit better. Let's make, like maybe a car company is working on a new car, or a software company is working on new software, but they still patch the old one, sort of type of situation.
Yeah, so I'm a rollup maxi. And the way that I think about scaling the L1 is actually making the L1 a rollup and making it the best type of rollup, specifically a based and native rollup. Right? Why is it a based rollup? Because the L1 proposers are proposing the blocks. They are the sequencer for the L1. And why is it native? Well, because the EVM state transition function is secured by the validators. By construction, it's bug-free. And by construction, it's EVM equivalent. And by construction, it evolves with every single hard fork. Now, why is it important to have one canonical rollup? Well, it creates a shelling point for various things. One of the shelling points is that it is around bridging and settlement, and being this hub for liquidity. So like one kind of classic problem that we have is, let's say we want to compose synchronously between two L2s, but now we need to have assets somehow go from one L2 to another. And traditionally, the way that these assets move is through canonical bridges that bridge back to the L1. So sure, we can do synchronous composability between L2s, but now we have this other problem that every time you want to actually meaningfully move assets around, you have to go through the L1. And so now you lose the scalability. So having the L1 have some minimum threshold of scalability will help smoothen these transfers from L2 to L2. Now there are some like very advanced designs, things like Ag Layer that have like shared deposits, where you don't have to go through the L1. It's kind of a pot of deposits that's shared across the L2, so that you don't have to touch the L1. But what we found is that there's just so much friction and coordination to achieve that, because you have these competing forces that you don't want to collaborate. And so in some sense, this goes back to my comment around credible neutrality, right? We need a credibly neutral sequencer, but we also need a credibly neutral shared deposits layer, and that can be the L1. Now, another thing that I'll highlight is, around this potential like pragmatic short-term pivot, just to keep people happy. Now, I think it's a fine way for people to perceive it, and it's a fine way to narrate what's happening. But ultimately, the fact that the L1 can become a rollup is due to technical innovations. It's not some sort of a top-down central bank. We're gonna play around with interest rates in order to make the L1 more attractive. It's fundamentally just a research unlock, an engineering unlock, whereby in order for the L1 to become a rollup, we need real-time proving. So I mentioned there's these two types of rollups. There's the optimistic rollups, there's the ZK rollups, and neither of these two types of rollups really work for the L1. And the reason is that the L1 needs to be settled in real time. This is one of the properties that we have today, that everyone in the world can agree what is the state of Ethereum at every single block. Now, unfortunately, the optimistic rollups, they have the 7-day dispute window, and so you have 7-day delayed settlements. That's no good for the L1. And then you look at the ZK rollups. Traditionally they will have maybe 1 day or 1 hour or a few minutes of settlement. That's still too slow. What we need is kind of slot by slot settlement, and this is only something that we've had literally in the last few weeks. And so it's only now that we can start talking about turning the L1 into a rollup. And again, like the fact that there's at least one canonical, credibly neutral rollup means that it can serve kind of meta services for all of the L2s, not just settlement, but also other things like shared deposits. Now, maybe the L1 is like not sufficient long term for these meta services, and we're going to need more sophisticated designs like Ag Layer and whatnot. And so I think it is very important to work on these things. But pragmatically speaking, it's kind of a nice coincidence that we've been trying to work on these things, and that some of these things turned out harder than we expected. And so there's a little bit of short-term relief due to the fact that the L1 is scaling. And again, I've been a proponent of base sequencing and native execution, and scaling the L1 in some sense is the most straightforward way to push these values. If you look at base sequencing, it's all about network effects. And how I mentioned that part of the challenge with choosing and adopting a shared sequencer is around incentive alignment. So when we look at the economics of being an L2, there's two ways in which you can make money. The first one is with ordering of transactions, also known as MEV, and sequencing. And the other one is basically using congestion fees, which is the equivalent of the base fee at L1. You have a certain gas limit, and if there's more demand than the gas limit or the gas target, then base fees start kicking in, and you start making money that way. Now, my expectation is that as the space matures, there's going to be less and less money to be made from MEV, and more of the money is going to come from congestion fees. And the reason I'm kind of short MEV, I'm kind of bearish on MEV, is because we increasingly have more and more sophisticated infrastructure that basically give the MEV back to users and applications earlier in the pipeline. So if you think of the MEV pipeline, we have the user originating a transaction, and then we have the wallet, and then we have the application, and we might have builders and relays and all sorts of intermediaries, and only at the very end do we have the proposer, the L1 proposer or the L2 proposer. And what's happening is that all of the entities that are closer to the user, including the user themselves, they're starting to recapture the MEV for themselves, and it's not leaking anymore so much to the proposer. And so really what you want to be doing as an L2 is maximizing congestion fees. And in order to maximize congestion fees, you want to maximize traffic. Like you want to have as many transactions as possible touching your state. And in order to do that, you want basically valuable money Legos within your L2 that others want to compose with. And you want to be connecting your L2 to the most valuable sequencer, so that you create these synchronously composable Legos. And right now, there's limited activity on the L1. So if we make the L1 more attractive, then it will basically mean that the L2s will have more incentive to become based, because they'll have more network effects from the traffic that originates from the L1. Like one very simple kind of classic example is, let's say that I'm a user and I want to make a trade, and I want to get best execution, and so I'm going to route my trade through all of the L2s that share that are within the zone of composability. And if there's some liquidity at a better price within, like, let's say, a handful of L2s, well, that single trade from one user will actually route through all of these handful of L2s and create congestion fees in all of the L2s. And this is something that's just not possible today. So if you look at aggregators like 1inch or Matcha, they don't work across L2s. And the reason is that you don't have this synchronous composability. They will work within a single zone of composability, so across dexes within a single L2 or within the L1, but not across the L2s. Yeah.
All right. Let me unpack the question of scaling the L1. In your definition, it sounded like scaling the L1 itself also means turning the L1 itself into a ultrasound rollup, essentially like a based and native rollup of sorts. How is that different from another ultrasound rollup? Is the L1 rollup a bit special? For example, just out of the top of my head, I would be thinking the L1 rollup maybe doesn't use the execute precompile. It is a bit different in that regard. Maybe it does, I don't know. Or maybe you don't have like any based preconfirmation abstractions, but you have more direct integration with the proposers. But yeah, can you quickly just unpack that, because that didn't quite click for me yet. The question is, would this L1 rollup be different from other ultrasound rollups that we want to build in the future? And also maybe start with explaining, once we like have this L1 scaling, this is actually for L1 users, right? This is not like I'm sure there's nice side effects for other rollups composing with the L1 rollup, but this is still for an actual L1 rollup user. And our goal here is to get gas costs down and also to increase speed, because of course Ethereum today is still pretty slow. Is that like what sort of features are you maximizing for while keeping the main value prop of Ethereum constant, which is decentralized censorship resistance, right? But yeah, those are my questions about that topic.
Yeah, great question. So how is increasing the gas limit for the L1 different from a native rollup? So you're right. Like the most naive way of dramatically increasing the gas limit does not involve introducing a new precompile. It can actually be done without any hard forks, which is kind of very interesting. The only thing that will happen basically is that the validators, instead of running normal execution layer clients like gef or ref, they would run the zk equivalent like zk-gef and zk-ref. And this doesn't need a hard fork. It just requires the operators updating the software. Now we can go like one step further, which is to expose this precompile and turn the L1 into a smart contract of an even more meta thing. So what we could do is basically make the L1 completely stateless. So we take all of the current state and kind of push it into a smart contract, which would be a native rollup using the execute precompile. And at that point, it really would be a native rollup that's built out of a smart contract, and then the L1 wouldn't have state anymore. It would be kind of a purely stateless thing that just runs the execute precompile and things like that. But we don't have to go that far, in my opinion, to still call the L1 a rollup. And the reason is that the definition of a rollup is a chain where you're posting the data on chain, so you have on-chain data availability, but the execution is done off-chain, and those that are enforcing the state transitions have to do very, very little work. They have to play this fraud-proof game, which is very, very cheap, where watchtowers and challengers are doing the real work of executing the transactions and posting challenges, or they have to verify snarks and other people do the real work of executing and generating the snarks. And I think as soon as all of the operators have updated their software, it's arguably a native rollup at that point. But I guess semantics. Now to answer your question around how is the L1 different, well, it would also be different philosophically, in the sense that it was the one that came from the L1. It has special state, in the sense that it has that's where the ETH was issued. That makes it special. It's also where a lot of assets are natively issued. And just because it's the first one, it's kind of credibly neutral, and also from a branding perspective, right? It's the Ethereum brand as opposed to being the Optimism brand or the Arbitrum brand or something else, and that gives it, I think, sufficient credible neutrality in order for it to play a coordinator role across L2s that require this neutrality.
Gotcha. Okay, so ultimately, what is Ethereum's purpose, right? Even in the future as an L1, I would personally argue, like you said yourself, rollups. Let's first define what rollups are. Like rollups are blockchains that post their blocks to another blockchain, essentially, right? And usually rollups are in a thing in the modular blockchain architecture, where it means, hey, I'm using another blockchain for consensus and data availability. This is the publishing your blocks to another blockchain part, right? But I'm handling execution sort of in whichever way I want to handle it. Actually, if you follow my reading or my articles, you will see that last year I got pretty much pilled on this idea of a sovereign rollup, which is very different from an L2 on Ethereum, which is actually, hey, you just post your blocks to another blockchain, and all of the execution you still do on a rollup node, and there's no concept of an L2 smart contract or anything like that. So you don't like, for example, there's a naive rollup, a pessimistic sovereign rollup, not using fraud proofs or ZK, where all of the rollup nodes are just full nodes like they would be for an L1, re-executing everything, right? And it's funny, I saw this topic of re-execution also coming up on the native rollup side. But yeah, so I mean, normally, like, Ethereum is catering towards L2 specifically, and not, for example, sovereign rollups, because really the purpose of L2s are a kind of rollup. Most people equate L2s to rollups, which is actually strictly not, like, the L2 is just one type of rollup. And specifically, I would say L2s are rollups that, yes, they post their blocks to another blockchain. Yes, they use Ethereum, for example, for consensus NDA, but also they maintain a smart contract-like client on that other blockchain for settlement, right? What does this mean, this gibberish? It means, hey, you use Ethereum for ETH, the asset, and you put it into a smart contract on Ethereum and to bridge it into your rollup. Therefore, you don't just get the sort of censorship resistance of the inclusion, right? Like for your rollup, you also get a smart contract custodying your assets on the settlement layer, right? So you now have what we call a trustless bridge. And I think the whole point of L2s in the history was you already had sidechains back then, and sidechains you can think of as sovereign rollups a bit. The difference is that they weren't rollups, they weren't modular, they were just like, they had their own validator sets and so on, versus rollups usually borrow validator sets from somewhere else, which is a nice sort of architecture. But they didn't have this trustless bridge. And like L2s and rollups on Ethereum, they came from sidechains being hacked, essentially, right? Like Ronin, you know, Beamchain. There were so many bridge hacks in these multi-sig bridges that we said, hey, yes, multi-chain is the future, but we need this settlement layer still, and we need this this trustless bridge, right? And that's how that's how fraud proofs were invented for optimistic rollups, L2s, and that's how ZK proofs got invented and are being invented. And they grapple with the issue of, okay, how can we make this trustless bridge still very fast, like the counterparts, like the layer zeros and so on, that are using attestation-based multi-sig bridges, right? So yeah, in this sort of L2 definition, for me, Ethereum's purpose is, and this is the primary purpose, especially with execution moving on chain, off chain, especially once you have ZK, right? Like, there's also ZK can do more than just rollups. I think Uma and Layer Zero recently tweeted again about ZK apps. Like, it is possible to have ZK apps that are very centralized. They're just verifiable, but they are not censorship resistant. So I think the ultimate purpose of Ethereum is to serve for global censorship resistance. And censorship resistance itself is just a means to an end. I think what censorship resistance gets you is permissionlessness, and sort of permissionless, I think, innovation, right? Because if you have someone who can censor, permissionlessness is like, that censor can also permission, right? So I think that's the like goal, like global, credible, neutral, permissionless business, permissionless trade, permissionless commerce, everything, and that's huge, right? And for me, that's Ethereum, right? And in general, that's rollups and decentralized BA and consensus, the idea of modular blockchain. That's the main export. But you also, I think, usually Ethereum is also positioned in that world as an asset issuance layer, right? And first and foremost for its own asset ETH, which, I mean, if you want a clean version, a trustless version of ETH, you should have this trustless bridge, and you should be an L2. But Ethereum also used to position itself for other assets, like as an asset issuance layer. So in this sort of evolving world of Ethereum becoming a rollup itself, potentially the L1, do you think, like, I mean, first of all, I'm sure you agree about the censorship resistance part, but maybe let me know if I forgot something else that's really crucial. But I would say, if you reduce Ethereum's value prop and blockchains in general, public blockchains in general, down to the essence in the world where ZK can handle verifiability for you, it's really just about having a censorship resistance database worldwide. But yeah, in this new world, do you still want to position Ethereum, whether it's Ethereum today or the future of Ethereum, where it's a rollup itself, as a asset issuance layer, where you encourage digital assets to be minted and from there added to trustless bridges to the rollups that compose with Ethereum?
Yeah, so there's a lot to unpack here. On your last point around, where should asset issuance happen, I think it does make sense for it to happen on the most secure platform, which arguably is Ethereum L1, so that if and when an L2 gets broken, for example, the sequencer gets taken over, there is a credible path for users to force exit their funds. Because one of the issues that we're seeing is that the security proposition, value proposition of rollups is diluted if you can't force exit. And even though technically you can push transactions through as a user with a large delay, for example, a 24-hour delay or a 1-hour delay, really what we want is the ability to withdraw the assets so that you can put it on another L2 that has strong liveness, where you don't have to wait this very long delay, and you don't have to pay high fees. And unfortunately, if the asset is minted and issued on the broken chain, then the asset itself is kind of compromised. And this goes back to your comment around sovereign rollups. Like, maybe one possible solution is for the community as a whole to say, hey, the asset that we issued on the L2, well, now we're just going to create a copy socially on another L2, and that's going to be the new source of truth, and we're going to just deprecate this compromised asset on the compromised L2. But that requires a lot of coordination, right? It's a social thing, which is difficult to pull off. Now, around the goal of Ethereum, in my opinion, well, one of the memes that I have in my mind, one of the mental models is internet finance, and we really want to scale it to all of the applications and on the internet that touch finance. And my belief is that the platform that can achieve that is going to be winner take most, just because of the strength of the network effects. Right? It would be kind of crazy today to build a communication network that doesn't go through the internet, right? Just because so much is built on the internet, that the fact that you're going through the internet gives you a lot of network effects. I mean, sure, like maybe there's some like crazy like military applications, where they never touch the internet. It's like a completely parallel thing. And I'm sure such things will exist in the context of internet finance, but the vast majority of activity, I think, will happen on one place. And we need to build towards this end game where we're going to be doing millions of transactions per second on the internet of finance. And the L1 is never going to be able to cater for all of that, just because the EVM or any virtual machine has fundamental limits around sequential execution. If you have multiple transactions that all depend on each other, then you can only execute them as fast as your processor can run. And like traditionally, your processor will run, let's say, a really fast one, like 5 gigahertz. And so just as for the sake of argument, like if you can do one transaction for every 1,000 cycles on your CPU, then at most you'll be able to run at 5 megahertz, so 5 million TPS. But in practice, we're not even anywhere close to 5 million TPS. Like the most that we can do, very roughly speaking, is about 10,000 TPS. Even Solana today is very, very far from 10,000 TPS. They can do about 1,500 user transactions per second. And so if we do want these 10 million TPS, then we fundamentally need to embrace this vision of L2s. And I think this is where the Solana vision doesn't really make sense. Like, yes, it makes sense in the short and medium term, but once they reach the 10,000 TPS, they're kind of going to be maxed out, and they're going to need to think out of the box of the monolithic or integrated vision that they have. And the good news is that when you scale with L2s and with blobs, there is a pathway towards 10 million transactions per second, which is about 100 transactions per day per human, which should be more than enough in my opinion. And the rough back of the envelope calculation is that you start with your really naive execution, which can do 10 TPS, and then you scale it with rollups that gives you a 100x optimization, which brings us to 1,000 TPS, and then you scale with blobs with data validity sampling specifically that gives you another 100x to 100,000 transactions per second, and then you have what's called Nielsen's law, which is the equivalent of Moore's law for bandwidth, which is 50% per year. And so if you compound that over 10 years, that's roughly 100x, which brings you to the 10 million transactions per second. And the reason why I focus specifically on Nielsen's law and bandwidth is because that's the only fundamental bottleneck for consensus. All of the other computational resources, whether we're talking about execution or state or disk I/O, all of that can be solved through SNOCs, where it's basically no longer a bottleneck. Now, another point that you brought up is around definitions, and it's kind of fun that you think of rollups as L2s being a special case of a rollup. I actually think of it as the other way around, where there's this class of L2s, which are basically chains built on top of an L1, and then within the L2s, there's these two categories. There's rollups that post data on chain, and then there's non-rollups that basically post the data to some other L1. And the two terms that we use are validiums for non-rollups that are secured with ZK for execution, and then you have optimiums, which are non-rollups that use a fraud-proof game. But again, all of that really depends on your definitions, and you're right that in practice there's a lot of confusion between L2 and rollup. But my definition of rollup is just when you post data on chain, and so in that context, the L1 it's kind of a rollup by construction because the L1 data is posted on chain as opposed to being posted to another DA layer such as Celestia.
Yeah, actually, let's go a bit more into these definitions because I think they will pave the way as a segue for understanding rollups a bit better, and then opening up the conversation to, double click on native rollups, based rollups. Yeah. So like you said, I think your definition is L2s essentially is where you start, and then L2s come in rollup forms, L2 rollups, right? Like, what does this mean? It means that the L2 uses Ethereum for DA and consensus, and then non-L2 rollups, meaning that they use alt DA for consensus. But I actually think the guiding principle, and we've been running Gelato rollup as a service for 2 years now, and we have a lot of sort of on the ground experience with the multiple stacks on Ethereum. Like we started with Polygon CDK back in the day, OP, Arbitrum. And nowadays we also have like a Celestia sovereign rollup sort of experimental stack. And one thing that I noticed is one critical question that I always had for L2s is, a lot of our users wanted an L2 or took an L2 stack, but they didn't end up using the bridge, this L2 bridge, this canonical bridge. And actually, I think this is a very defining factor of an L2. Again, I think this is coming from the history of L2 rollups, which, I mean, used to be the same word as rollups. Most people, when I say L2, they think rollup. But actually, what was very the determining factor for the L2 was like, there's a smart contract on Ethereum that the L2 has to not just post blobs to, or DA, like the L2 doesn't just use Ethereum for DA, it also uses Ethereum for essentially state transitions, right? And why does it do so? Well, it has a smart contract on Ethereum that has funds in it, assets in it on Ethereum, and they need to be locked or released based on the state transition function of the L2. And here I think the issue that early L2s have is that this bridge is very slow. Like you said, for optimistic rollups, it's a 7-day delay. And you can almost disqualify it as a bridge because every end user won't use that, right? As we see, actually, they all use either they use abstractions on top of that bridge, like a cross or something, like a market maker to make it seem fast. Or there's like even many L2s don't even have asset issuance on Ethereum anymore. They use like layer 0 OFTs, or of course Circle has their own mint and burn asset, where the actual asset doesn't sit in the L2 bridge on Ethereum ananymore. It's sitting on a server, like on an attestation server that is outside of this trustless bridge system that the L2 actually originally was designed for. So I feel like L2 is like, I define it from the perspective of the bridge more than even the perspective of the rollup side. And that's why, like a sovereign rollup, I sometimes call it not a rollup L2, but a rollup L1, because it's still a rollup. It uses another, like a sovereign rollup, by the way, could be on Ethereum as well, right? Like it was a concept invented by Celestia, but it might as well be on Ethereum, where the idea is, okay, you want a chain, but you don't want to bridge to Ethereum for whatever reason. You can still use rollup technology to get decentralized DA and consensus, but that other chain isn't defining your assets like your bridge anymore. You might be a rollup that has, for example, a in-game asset or a meme coin as the native currency of that rollup. That thing doesn't exist on Ethereum, but you still want to use Ethereum on the rollup node so that everybody running the rollup knows, okay, I can have inclusion guarantees, decentralized sequencing, whatnot with Ethereum, right? So you still get the benefits of a rollup. But broadly speaking, I want to say that I definitely separate this market into like Ethereum L2s, which I think today there has been some confusion about, okay, what's the value prop of Ethereum if so much of the TVS is not even in the bridge anymore? And we certainly had some customers who had 0 in the bridge, right? Like they literally didn't want Ethereum to be in the picture at all. So like I would sort of separate the market into Ethereum L2s, where today we talk about like how can they be better? How can Ethereum, be used better for L2s? Like, that's where native rollups, based rollups come into play. How can we get rid of these security councils? How can we get rid of the 7-day delays and so on, right? At which point I think Ethereum is super attractive again as an L2 layer. And then you have use cases that want to be rollups, but maybe they don't want to have, or they don't have to be a native rollup on Ethereum because they just don't care about anything that's happening on Ethereum, but they still should be a rollup. But yeah, so that's sort of a lot to unpack there, where my definition is coming from. And I feel like in the Ethereum L2 narrative, it's very important to focus on the settlement and this bridging part. And what's like, why is I mean, I have some data to show. I think I already published it in some of my articles, but I will publish another article soon. The motion for an Ethereum Settlement Score, which is essentially a sort of motion to update the L2 beat metrics to introduce more stages, and especially actually use real empirical data to score an L2. Because if you look on L2 beat, we all know that the only rollup with all green slices is also the last one on the page. So there's something seems to be broken about this, right? So I think we can update L2 beat's metrics to and essentially admit that current L2s still have to go through a couple of updates to be truly fulfilling the mission, which is to inherit Ethereum security. But yeah, that's a lot to unpack there. And for me, this is the conversation about what needs to be updated about Ethereum and L2s, even to make it more credibly neutral and to make L2s not like so much of a meme like they are today, sometimes where there's like a security council that can be compromised easily. Or where most of the assets on the L2 aren't even on Ethereum. I think a core question is like, why is that, first of all? I believe there are technical reasons for it, not only, right? There are, but definitely technical reasons, which is like, hey, this 7-day bridge just doesn't work. It's not practical. And then how can we improve that, which roughly boils down to just make it super fast, right? And that's where real-time proving comes in. Make it super fast and make it not lose the core property of Ethereum, which is censorship resistance and so on, right? And that means making it super fast means ZK, basically, real-time proving. And similarly, ZK also plays a key role, I suppose, for native rollups, sort of making it censorship resistance and not having, multi-sig custody of the bridge. But yeah, that's the opener for the next section, I guess, of the pod.
Yeah, it's very interesting how L2 beats only captures like a very small slice of what makes up an L2. And I agree with you. It kind of, probably needs to be updated as the space matures. One of the things that I'll highlight is that the sequencer is not part of the equation. You can have a totally centralized sequencer and still have all green slices. And you make a similar comment around the bridgeability, which is a topic I haven't thought about, but I love that you have this bridging first viewpoint on the world. I guess I have a few comments about the bridging. The first one is that we do have at least one sovereign rollup on Ethereum called Facet, which also happens to be a base rollup. And the founder is an interesting character, and I would recommend you talk to him. Another thing that I'll say around bridging is that I don't see it as being black and white. I kind of see it as a spectrum, almost as a percentage. And the reason is that you can take a sovereign rollup and you can build bridges, and those can be trustless bridges. So you can take Facet, for example, and anyone can permissionlessly deploy a bridge at any point in time. And that can be a bridge which is using fraud proofs or snarks the traditional way and have state roots that are posted on chain. And likewise, as you suggested, you can take a kind of canonically bridged rollup, and then you can build these almost like sovereign or like trusted bridges. And so maybe what we should be doing is like looking at the total value secured or total value locked, and looking at what percentage is kind of trustlessly bridgeable back to DL1 and what is not. And maybe there's an opportunity for a new meme, right? So we have base, we have native, and we need some sort of new word to describe this thing that is kind of trustlessly bridgeable back to DL1. Maybe exitable or bridgeable. I kind of need to brainstorm this, but it is definitely an interesting viewpoint. And maybe for people to really understand the importance of this, we need kind of, it sounds a bit masochistic, but we need some sort of a hack to happen, right? For people to understand. So if a rollup gets taken over and people can't withdraw the assets that are natively minted in DL2, then that might be a wake-up call for the community. I forget who exactly is building this, but I think some people out there are trying to build alternatives to L2Beat that kind of highlight these different things. And having one kind of L2Beat for bridges would be hugely valuable.
Yes, and teaser, we're not building a competitor to L2Beat, but I'm gonna file a motion with the Ethereum and L2Beat community very soon, which I call the Ethereum, the motion to introduce an Ethereum Settlement Score. I could share my screen maybe later in the podcast, maybe not, but it just very roughly speaking, the point of it is to introduce new stages. I don't know the definition of L2Beat stage 2 verbatim. It doesn't even matter so much, to be honest, because I think almost no rollup is stage 2 nowadays, no Ethereum rollup, except for the one with like $50 in it, Fuel V1 or whatever. Shout out to them. But yeah. So first of all, I think this Ethereum Settlement Score, again, I'm going to publish the draft soon. But it introduces a scoring system and weighting system based on how much of the L2 TVS is actually in the canonical bridge on Ethereum, versus how much of it is completely like custodied by third-party bridges, external bridges. It also looks at how fast is, or like, how long is the force inclusion time? You mentioned this is super key, and actually I think this is the biggest weight is, like I always say, the thing that Ethereum exports first and foremost is censorship resistance, right? Which you could say is essentially decentralized sequencing, right? This translates into the ultimate rollup should be based. It should be a base sequencer on Ethereum. But yeah, I would say if your rollup, if your L2 has a force inclusion window of 10 days, that's not great, because that is still a high degree of censorship, actually. Many trading positions, if you can only exit them within 10 days, is completely meaningless that you have that exit window, right? So force inclusion and censorship resistance needs to be seen through the lens of time as well, and speed. And it all boils down to, like, it seems to be the core essence of technology is just make everything faster always, right? So I feel like here, like a core weighting for L2 should be how narrow is their force inclusion window for users, and of course the narrowest being the same as Ethereum, which is like base sequencing, I guess. And then we could talk about Ethereum censorship resistance itself, but this is we disregarded in that conversation. Of course, Ethereum also has inclusion lists coming and so on to even on the L1 layer fight censorship, right? But then other weights would include, okay, looking at actual empirical data, like, again, how much of the TVS is in the actual Ethereum bridge, and if you look at on L2B TVS metrics today, or on the Dune dashboards that we will publish soon, you will see that the poster children rollups like Base or Arbitrum today, they have like about 1/3 of the TVS on Ethereum. Most of it, of course, being ETH, the asset itself, and then maybe rep Bitcoin or something like this. But yeah, so and then also the bridging volumes in and out of the rollup, like how many of the users are actually using the canonical bridge, bridging volumes, and actual distinct addresses. And of course, everybody knows that no human is using the canonical bridge, which actually is, we lose little bit of security there, potential benefit, but volume wise as well, like a lot of the volumes are not going through the canonical bridge. Of course, a lot of the volumes are just Circle, like CCTP minting USDC themselves. And this is like all of this we condense into the Ethereum Settlement Score, which also then incorporates the stage system. But we extend the stage system to stage 3, which is native rollups. This means no more Security Council. I think stage 2 actually allows for Security Council still, which I thought was pretty interesting. Like, I think that's not good enough, right? So stage 3 is no more Security Council, native rollups. We can go a bit into that topics now. And stage 4 is just a meme. Like, that's essentially ultrasound, you would call it, like native and based, plus an ESS of 1. An ESS score will be between 0 and 1, factoring in the weights that I just mentioned. Again, a lot of it is force inclusion windows, actual empirical bridging usage, and then even like a small penalty applied to L2s that have a lot of native asset issuance, i.e. like on Base, for example, you have quite a vibrant ecosystem today of tokens that are just minted on Base, like Kaito or VVV or Arrow. These tokens are not minted on Ethereum. They are minted on the L2 directly, which makes the L2 like a bit more like a sovereign settlement layer, which I think is taking away from Ethereum's value prop. Like, I think it makes sense what they do right now, but I think Ethereum in the future, once it's faster and cheaper to get these assets from Ethereum, mint them on there and get them into the rollup, could serve as a nice sort of settlement layer there again. But yeah, so all of this weighting will really shine some sunlight on the current state of things. And then I think there's a very clear path to achieving the full utilization of Ethereum again, which essentially just means that Ethereum needs to become a heck of a lot faster at certain things, and things like introducing the execute precompile and so on, like native rollups, right? But ultimately, the tagline for L2 should be, this is like Ethereum, this is inheriting Ethereum, right? And for this, we need to get rid of multi-sig security councils, and we need to have like ZK, real-time proving, and so on, right? So this is essentially the ESS motion that I will file soon, which has a lot of interesting data. But yeah, now let's talk about how we can improve Ethereum for rollups, like for L2s, and let's double click on the native rollup section, unless you have another topic you want to open.
No, I just have a couple of thoughts on what you just said. I love that you're kind of looking into detail into the bridging. One other detail that was highlighted by James Presswich is this idea that even if sometimes you can force include your transaction, that doesn't mean that you can actually do the action that you wanted. And the reason is that even if you can force include, oftentimes the sequencer can basically front run you, and they can basically have a transaction which fights back against what you're trying to achieve. So, for example, if you're trying to take out a loan, on Aave, and there's X dollars of liquidity. Well, you can have a transaction that just before you that takes out sufficient money from the pool so that you can't take out the loan, and then your transaction fails and reverts, and then you have a transaction after that that kind of repays the loan. And so maybe there also needs to be more clever mechanisms to prevent this attack. So one idea that just came here was, what if you can submit encrypted transactions, and then you submit the decryption key at some later point in time, or maybe it's based on VDFs, or maybe it's some sort of fancy inclusion list where it's a top of block inclusion list for some distant block into the future. I haven't really spent much time on this, but maybe there's a design space there. And one word that just go ahead.
Yes, no, I don't want to interrupt your train of thought, so I'm going to ask my question in a moment.
No, and then just going back to the meme, like just one word that came to mind, which may not be good, is grounded, right? A rollup is grounded if the assets are minted in the L1. But that's something I still want to brainstorm on with you, I guess.
Yeah, I guess backed or something, backed by Ethereum, no, not the best meme. But ultimately, now I lost my own train of thought here, but let me quickly... What did you say before you mentioned the grounded meme?
The James Pressfield attack where you
yes, force inclusion. Okay. So first of all, of course, you can never be secure against malicious smart contracts, right? So the first base assumption that we're operating with is that the smart contract that you use on the rollup is also permissionless, right? And that its rules are not malicious toward the smart contract. They cannot be, the rules cannot be manipulated against you by an operator, right? That's the whole point of smart contracts really on blockchain. So that you will never be safe on rollups against smart contract hacks. That's not the point of a rollup or an L2, right? So about the point that hey, maybe a sequencer can still front run you or something. I think now we're really this is really nuanced, but I would say so maybe let's not start with native rollups. Let's start with based rollups and the notion of decentralized sequencing. I wanted to steer a bit away from it because for me, there's two ways to discuss based rollups. There's the one that I really think is I care about a lot, which is decentralized sequencing without introducing your own decentralized sequencer, which I never understood why projects even try to do that. I think the whole point of a rollup is to leave sequencing and consensus to the L1. If you start building your own decentralized sequencer, I feel like you're just doing something wrong, or you're just rebuilding Ethereum from scratch, which is beside the point, I think, of modularity. So base sequencing makes a lot of sense because you get decentralized sequencing directly delivered to you from the L1, which is already part of the commercial contract that you have as a rollup with the L1. Is you import that, right? So I think it's interesting because normally rollups, they just import DA and consensus, but they usually they run execution, right? But with but they introduce their own preconfirmations. Because why? Because Ethereum is slow. That's the only reason. The only reason is Ethereum doesn't have single slot finality or whatever. It takes 40 minutes to finalize, blocks at 12 seconds. Ethereum is slow. That's the only reason why we even have these centralized preconfirmations. I think there's some others, of course, but so if we for me, the interesting thing about base sequencing, which I would like to discuss first, is decentralized sequencing and force inclusion. And then we can jump about the other topic, which I know you love, which is, it's synchronous composability as well between rollups, and especially between rollups and the L1. But before we go to sync composability, which is an insanely complex topic, let's first start with hopefully a bit simpler topic, which is, hey, what if we remove the centralized sequencer? Because what happened with L2s is they introduced the centralized sequencer, which is in a way fine, it is, great UX, but it is losing a lot of the benefit of being on Ethereum, which is censorship resistance. And the base rollup is essentially just saying, hey, there is no centralized sequencer anymore. Every rollup node is just syncing directly from the Ethereum DA layer. Now, the problem with that, actually, interestingly, Arbitrum started like this in 2018. They literally, I think, started as a form of based rollup in their naive first implementation, but then very quickly realized, oh, we can still get more performance and cost efficiency if we go and have a centralized sequencer. And it's, most of all, we can go faster. Like we can go 500 milliseconds if we give these centralized preconfirmations. But what I didn't quite understand in the James Presswedge point is, I feel like there's varying definitions of what based rollups are. Like some of them still have this sort of separate sequencing set, but for me, like the one that I care a lot about is this total anarchy idea, where it's like, hey, the rollup node is literally run directly from Ethereum. And at this point, I wouldn't understand how a centralized sequencer can front run you unless that centralized sequencer also happens to be the proposer in the same slot, right? But ultimately, you should have the same private lines even to Ethereum proposers, and you should be able to get your transaction included in Ethereum, and ergo in a total anarchy-based rollup in the rollup as well, so that all other rollup nodes also ratify it and ratify the ordering of it. So yeah, why do you think would that still be an attack vector, and what's your definition of a based rollup?
Yeah, so I don't think it would be an attack vector. So once you have a base rollup or decentralized rollup, you don't really need the forced inclusion anyway, because the primary mechanism is itself censorship resistant. And so that is the forced inclusion mechanism. In some sense, you're collapsing two things, the forced inclusion and the primary path, into just one primary path. And that's kind of nice simplification for...
Sorry, then maybe I understood your point wrong. Maybe the point was just about current day forced inclusion or something. But yeah, for based, I don't
current day forced inclusion. Yes.
Okay. All right.
Yeah. Now, in terms of what is my definition of base rollup, it basically is a rollup that uses a subset of the L1 validators as proposers in their respective slots. So if for slot N you have proposer N, well, you need to use that entity, proposer N, as the sequencer for in that period of time. But the reason why I mentioned subset as opposed to all of the validators has to do with the pre-confirmation. So the only way that I found to have robust pre-confirmations with the base sequencer is to have a subset of the L1 validators opt in to becoming pre-confers. And the reason why you need this opt-in process is that if you just have everyone be a pre-confer for their respective slots, then you won't have pre-confirmations at every slot. You only have it on the percentage of slots that have opted in. And that's just terrible UX, right? We want to have pre-confirmations all the time. And so the idea is that you imagine the set of validators kind of on the line, and a subset of them have opted in, and then there's gaps in between. And basically the sequencing rights, whenever there's a gap, is given to the very first sequencer that breaks the gap. So for example, if you have slots n plus 1 and n plus 2, and validators n and n plus 2 have opted in, but n plus 1 hadn't opted in to provide pre-confirmations, then basically slots n plus 1 and n plus 2 form a bigger slot, a 24-second slot, and proposer n plus 2 now has sequencing rights for those two slots, and they can issue pre-confirmations in particular for those full 24 seconds. And the way that you opt in as a pre-confer is that you post collateral in a smart contract, for example, and that collateral is going to back the promises that you make for your users. So if you promise a user to include them in position 13, and the transaction will execute in such and such a way, and you don't fulfill your promise of including it in position 13 and executing in such and such a way, then you get slashed. And you can even, if you want, have an insurance mechanism such that the user gets refunded if their promise is not held. And then we can dive into this, but there's a whole design space as to how to build these things. And there's all sorts of subtleties around, for example, what's called the fair exchange problem, whereby as a user, I make a request to a preconfer to have my transaction pre-confirmed, but the proposer never responds with a response. So he gets paid to make the pre-confirmation, but the user never gets the benefits of that. And then there's another problem, which is called the pre-confirmation pricing problem, which is that by making a pre-confirmation, the proposer is limiting optionality that it has, or they would have had at the end of the slot had it not made the pre-confirmation. And like the classical example here is with a trade. Like if you're promising a certain user to trade at a certain price, then that means that you won't be able to trade that asset, like the user has already traded it. And so that's going to affect MEV that you can extract at the end of the slot. And so one of the challenges is to make sure that it's always rational for the proposer to issue a pre-confirmation. They need to get as much MEV as they would have had they not given the pre-confirmation, plus a little epsilon to incentivize them to actually give the pre-confirmation. And so really what you need to be doing is pricing future MEV, which is a hard problem. There's also all sorts of a design space around how much collateral is required to back the pre-confirmations. And here there's some good news, which is that only a very low amount of collateral is really required most of the time. And the number that I've landed on is 1 ETH. And the reason 1 ETH is sufficient for almost all users is that when you look at the value of each slot with MEV-Boost today, so there's as your listeners probably know, every slot there's an auction where the different block builders bid against each other to get their blocks included. It's through this protocol called MEV-Boost. And what you can look at is the value of the bids that are made. And for almost all of the time, more than 99% of the time, the block is worth less than 1 ETH. And what it means is that the arbitrage opportunities within this one block is less than 1 ETH. And so as a pre-confer, if I'm making a pre-confirmation to a user, when will I have the incentive to renege my pre-confirmation? When basically there's so much volatility within the slot that now the best move for me is to capture the arbitrage as opposed to honoring the pre-confirmation. But that's something that happens very extremely rarely in the context of user transactions. But yeah, happy to answer any part of the design space, which is quite broad. But various rollups out there, for example, Tycho, and there's a whole list of them are trying to bring pre-confirmations onto mainnet this year.
Cool. So I have a lot of infrastructure-related questions there. I mean, again, just through the lens of decentralized sequencing, removing the centralized sequencer that, Gelato runs a bunch of centralized sequencers today for Ink, the Kraken chain, for example, right? Open Campus, the Animoca chain, Lisk, and many more. So I think, like, ultimately, where do we come from as in the blockchain space is usually running a node, right? Running nodes is essentially what used to define us from the early days of Bitcoin. And nowadays it's a bit like the waters are a bit muddied, because actually turns out that just running a node is not quite enough there. Like for rollups, like you have the centralized sequencer that you also have to rely on to properly post batches and so on, right? And total anarchy, like base rollups, I think they go back to, okay, technically you just need to run a node of the rollup, and you completely can sync from Ethereum, and Ethereum contains all of the data of the rollup at all times. There's no in the total anarchy, there's no weird like pre-confirmation thing that could go wrong or something. You're just relying on the normal Ethereum confirmations. There's no pre-confirmations, there's just Ethereum confirmations, right? But why are we even talking about based pre-confirmation still, right? Because today you have centralized sequencers who just have the trust me, bro, I'm a company, trust me, I'm gonna post this batch, centralized pre-confirmation. Then we have total anarchy, which is, okay, this rollup is like literally synced off Ethereum DA directly. And then in the middle, we seem to have this notion of based pre-confirmations that are bridging the gap sort of. And what is the gap that is being bridged? Like, it seems like the only thing we're dealing with is like sort of speed and UX, because we don't want a based rollup to go back and tell the users, you now need to wait 40 minutes for everything to finalize, or 12 seconds even for a single block, right? Which is the case if you are relying on Ethereum purely for sequencing today. That's the point of it, right? Like, you're back to Ethereum properties. So first of all, would you say that all of this complexity is worth the pursuits in the name of essentially making the rollup seem very fast still, backing that's sort of illusion almost up with some good guarantees, but not unbreakable guarantees, right? Like, that's what you mentioned with having a pre-confer sort of being a protocol where validators also have to stake. So like, why do you want to go this route, even though there's some trust assumptions and so on, and as a trade-off versus like trying to make the L1 much faster? I mean, probably because the latter one is harder, but yeah, that's my first question.
Yeah, great question. So my thesis is that any sufficiently decentralized sequencer will have slots durations that are too long. Even something which is rather centralized to my liking, something like Solana, has 400 millisecond slot durations, and I still think that's too long. Right? We want to have pre-confirmations that feel like Web 2, and really we should be talking about ping time latencies plus a little delta, which might be 1 millisecond or 10 milliseconds. So really, what we're talking about is this notion of a tick. So the new unit of time for pre-confirmations is a tick, and the tick duration should be milliseconds long, maybe 10 milliseconds. And so within one slot, you have many, many ticks. And I picked Solana with 400 milliseconds, but really, if you want to have kind of Ethereum-grade decentralization with home internet connection and very broad geographical diversity, your slot durations are going to be at least 1 second. And there's no way 1 second is going to be kind of good enough for many applications. And so my thesis is that pre-confirmations are necessary. There's just no way around it. If you want decentralized sequencing, we also need pre-confirmations. Now, what exactly does pre-confirmations solve? It's only a UX thing, and it doesn't solve another problem with long slots, which is around MEV. So there's this kind of known result, which is that if you take a naive DEX implementation, for example, Uniswap V1, V2, or V3, then the amount of MEV that leaks away from the liquidity providers is super linear in the slot duration, meaning that the smaller slot durations you have, the more efficient your protocol becomes, because there's less toxic MEV that's extracted from the LPs, and so ultimately the LPs are then able to post with tighter spreads, and that ultimately leads to better execution to users. And that's something that unfortunately the pre-confirmations don't solve at all. It's purely this cosmetic layer which helps with UX, but doesn't fundamentally help with MEV. So I think there's going to be a dual effort at play here. On the one hand, we want to shrink the slot durations as much as we can to improve the MEV, at least for these first generations of design. It's possible that we're going to be able to build better DEXs that don't leak so much MEV. And I think Uniswap v4, with all of these clever hooks, will allow for experimentation there. So that's one thing we want to do. We want to shrink the slot duration, but fundamentally we also need to tackle the preconfirmations. And another downside of preconfirmations is that they're not going to be perfect in the sense that sometimes a proposer will just happen to be offline, and just like there are missed slots today, there's going to be missed ticks in the future, and not only is going to be like a single tick that's going to be missed, but there's going to be a whole slot worth of ticks that's going to be missed. And so it's going to be a little bit like the internet today, where if you're traveling on your mobile phone, like every once in a while, your phone is reconnecting to a new 4G cell tower or whatever it is, and then you don't have a connection for a whole second or maybe a few seconds. And so the faster slots we have, the lower the downtime will be when you have this exceptional case where the proposer happens to be offline. Now, another thing that I want to highlight is that I think for some applications, we're still going to see centralized sequences, and that's for a couple of reasons. The first one has to do with these missed ticks, whereby with a centralized sequencer, you can have some sort of a SLA, I guess, where the vendor of the application, which could be a game, for example, will just make some sort of promise that they'll be online most of the time with many nines of uptime. But the other thing that's interesting as well is this idea of homogeneity. So unfortunately, in a decentralized context, you have diversity of participants, which means a diversity of proposers, which means that, for example, your ping time is going to change from slot to slot, right? Because the proposer, in slot N might come from the US, and then slot N+1 might come from Asia, and then slot N+2 might come from Europe. And so if you're playing a game, that's actually bad UX, right? Because, your ping duration changes all the time. So even though I'm definitely a huge proponent for decentralized sequences, we need to understand the limits. Limit number one, just to recap, is that it's possible that from an MEV standpoint, they will have worse properties than centralized sequences that that can have like really, really short slot durations, or can make promises around how they will sequence their transactions. And two is this notion of homogeneity, where the ping duration and the uptime is less predictable than for centralized sequencing.
All right, yeah. No, I think that's definitely a very good point. There's always trade-offs in engineering, and centralized sequencing, definitely has a future still. And like I said, also in the beginning, right, it really depends on your application. You might have an application that doesn't require immediate censorship resistance, right? Like everything is usually a spectrum. So it might be fine for you to have, a force inclusion within a 1 day or even 7 day window, right? Like that might be totally fine. Like if you have an application where it's like, hey, I don't know, I want to at least be able to migrate my assets out of here when I'm done. You might be willing to wait 7 days. That's fine, right? Like if it's not like unwinding super time sensitive positions, that censorship resistance degree can probably be a bit lower as long as it's still there. So yeah, it really depends on the application. Talking just a bit more about based preconfirmations. So how is this? I read a bunch of papers. Like I read about Tycho back in the day. I read about MEV commit. I read about there were different ones. So how is this gonna be built? Right? Is this gonna be in protocol? Is there gonna be an in protocol slashing condition for this at some point, even, or is this gonna be out of protocol?
Yeah, so there's a whole design space. We can have it in protocol, some sort of enshrined registration contract with enshrined slashing conditions. We can have it totally off protocol, and there's kind of something in between, which is interesting, which is that it's off protocol, but it's turned on by default in all of the client implementations. And that could also be something worth experimenting with. But what we have right now that's being built by Fabric, for example, is what's called the URC, Universal Registration Contract, which is a smart contract where you deposit your 1 ETH, you opt in to becoming a pre-confer, and they have this very kind of nice and clever way of doing slashings, which is that instead of kind of catering for very specific promises, for example, I promise to include your transaction, or I promise to include you in position 12, or I promise this and that. They have a very flexible framework where the slashing conditions are themselves programmable. So you can specify as a smart contract the bilateral agreement between the user and the proposer. And so as the space evolves, this one universal registration contract is fully compatible, forward compatible with promises in the future. And what needs to happen is that the various wallets need to integrate with this protocol. So they need to listen to the registration contract so they know who is which subset of the validators are pre-confers, and then they need to be able to send pre-confirmation requests that the pre-confers understand and are able to honor, and there needs to be changes, of course, at the UX level in order to show the green check mark as soon as you click send. Now, one of the complications with pre-confirmations today is that they go through the validators. And unfortunately, well, fortunately/unfortunately, we want the validators to be maximally unsophisticated. And in particular, we don't want them to be doing the pre-confirmations, because in order to give pre-confirmations to users, you need very, very high bandwidth, because basically you're doing pre-confirmations for all of the L2s simultaneously. You need to have very high uptime. You need to have low latency. You need to be resistant to denial of service attacks, right? Because there's one IP address that's receiving all of these pre-confirmation requests, and it's just totally unsuited for validators. And so the temporary hack that we have right now is this notion of a gateway, which is the equivalent of a relay for pre-confirmation. So this gateway is meant to be this neutral entity which mediates the untrusted proposers that have the sequencing rights and the pre-confirmation rights, and the users that request the pre-confirmations, in the same way that the relays will mediate the block builders and the proposers. And the good news is that this temporary hack will go away once we have APS, Attester-Proposer Separation. So as part of the Beamchain, I already mentioned that there's this idea to keep the validators completely disconnected from the MEV pipeline, and in particular, all of the pre-confirmations will be done through a market of much more sophisticated entities called execution proposers.
All right. So roughly speaking, how we can think about a based rollup working in the future is whether there's a gateway or we have APS eventually. Like ultimately, I mean, again, what do you have to do nowadays even to talk to a chain and to see your balances and use applications on a rollup chain? As you have to connect to usually a full node nowadays of this chain, like an RPC node of that chain. And this is usually wallets, right? Like if you remember on your MetaMask wallet, or like you usually add a new chain there, you add a new RPC if you want to talk to another chain, if you want to connect your public-private key to another chain and sign and send off transactions, right? Yeah, so essentially what this means is the RPC node infrastructure and really just the RPC node infrastructure that is also used by wallets and so on. They need to essentially be aware of this pre-confirmation protocol, and they then need to essentially, this L2 RPC in this case, this is an L2 using base pre-confirmation, and all of the RPCs that function properly on this L2 that have this feature, they essentially are aware of this overlay state protocol where they can update the L2 state more quickly based on these pre-confirmations, sort of advancing the L2 into this pre-confirmed future that isn't yet confirmed, therefore pre-confirmed, right? It's like there's like a whole sort of parallel universe time travel analogy that I can sometimes go into here, but I will spare you with this one today. But yeah, essentially all it means is now we're running nodes, and these nodes, they essentially talk to this pre-confirmation protocol, and based on that, they now, and of course, like the point of a node is that you can run it yourself, right? So if you're Binance usually doesn't work with an RPC provider. Binance usually a hard requirement for them is they can run a node and verify the chain themselves, right? So Binance can now operate a fast L2, not like today where they, I think for OP and Arbitrum and so on, they wait 14 minutes, which is roughly speaking Ethereum Finality. They don't wait 7 days, right? So they I think they usually wait for the batches to be posted on Ethereum and then for Ethereum to finalize. But these big merchants like our exchanges, they can now run this based rollup node, and they can have a good conscience, showing you state of this, honoring your deposits and withdrawals from that on that rollup within, I don't know, whatever the based pre-confirmation time window is, like ticks, like maybe milliseconds, right? Because why? Because they are comfortable with this protocol. They know that the validator will actually confirm the transaction. Why? Because supposedly the validator has some stake that can be slashed. Right, but true finality is actually only achieved again once Ethereum finalizes, right? But yeah, is that a correct description?
Okay, so there's a few things I want to talk about here. The first one is, as you said, there's this overlay protocol on top of the traditional RPC, and really the way it would work is that the gateways, which would be issuing all the pre-confirmations, have a stream that you can connect to, for example, a WebSocket connection. And every time there's a pre-confirmation, it kind of gossips that pre-confirmation to the whole world. And you can think of it as being first come, first serve, kind of pop-up block almost, where you're building the block in real time from top to bottom. And the terminology that we're using is actually copied from Solana. So I already mentioned we have ticks, which are the equivalent of slots, and we have the notion of a shred, which is the equivalent of a block. So a shred is a small part of a block, and you're building shreds from top to bottom every single tick. Now, another thing that you mentioned is if I understood correctly, a merchant being able to receive a payment, at the speed of a tick. Now, unfortunately, pre-confirmations don't work very well for this, and the reason is that the real world value could be much larger than the collateral. I talked about 1 ETH of collateral, which works great for things like MEV and arbitrage. But if you're buying, a house or a car, or if you're making a withdrawal from an exchange and you could withdraw $1 million, then 1 ETH is just not gonna cut it. So there's different use cases for pre-confirmations, and if you're talking about real world interactions or withdrawals, then you actually have to wait for inclusion in order to do a delivery. And if you're really paranoid, then yes, you want to wait more than just inclusion. You want to wait for finality. Yeah, in some sense, I think of finality as being useful for these real world applications where you want to have interactions that are external to Ethereum. But if you're only dealing with things that are internal to Ethereum, then pre-confirmations will work great.
Gotcha. So I think your pre-confirmation definition like you said, it's like the collateral. Like that's why you talk about collateral and the collateral requirement not being super high. Is all about essentially, giving a preconfirmation around ordering, and the only reason why that preconfirmation would be broken is if a reordering that was committed to could lead to a higher MEV extraction for that preconfirm than what they ordered in the last 12 seconds or so.
Yes.
Okay. All right. So I think probably, and I don't think we have time to go into that today, because I still want to talk about native rollups briefly. We should probably do a round 2.
Sure.
So probably that comes because like your focus is always usually then, I think, for based preconfirmations and so on, then very quickly goes to sync composability with the L1 and other rollups, where ordering is quite important. But yeah, I have a lot of questions now, because like this is why, like in my mind, I'm way more excited about base sequencing as total anarchy, where it's completely Ethereum. There's no overlay, there's no separate staking requirement and so on. It's just about, okay, this rollup has the same sort of inclusion censorship-resistant guarantees as Ethereum, which would mean that, like, first of all, this would only be cool if Ethereum becomes way faster, the actual base layer, which, I mean, there are, like, I think it has not been prioritized right now, but it could be prioritized at some point. And of course, for use cases that don't require this ultra low latency, right? Like you mentioned, 400 milliseconds is not enough. Like I'm sure there's some good use cases like banking, bank transfers or whatnot, right? Like that, even payments that don't have to be super low latent, or like, I know that payments also need low latency, but yeah, where maybe 500 milliseconds is enough, right? And that might be achievable.
ENS is becoming a base rollup. So ENS is deploying an L2 called Namechain, and they will be a base rollup. And if you're issuing an ENS name or renewing your name, whatever it is, it doesn't matter if it takes 12 seconds or 100 milliseconds.
Yeah, and I think like with the base rollup, the cool thing then is that you have this infrastructure layer, Ethereum, which is always there, that you can always rely on, right? And sure, you still need RPCs to be run, but you don't have this other operator like a Gelato rollup as a service does at the moment, right? Where you really, like, that operator is very crucial to the whole operation. With a base, like with a total anarchy based rollup, is like the base infrastructure Ethereum is always there. So yeah, sure, maybe you still need an RPC to be run for the applications to function, but that is less of a crucial role, because an RPC can be like just spun up any time of the day, right? You don't need to coordinate with someone. You just need to essentially spin up your node, connect to Ethereum, and you can run the rollup, right? So, and Ethereum is always there, highly available, and so on, right? So, it doesn't go out of business or whatever, right? So that's why I'm super excited about this use case. Although I agree that at the margins, it becomes very, like, there are some use cases that require that much speed where you always need some pre-confirmation and you can't just live off the L1 sequencing latency. But I feel like in a hypothetical scenario, if Ethereum had, let's say, a single slot finality and the slots were 6 seconds, you would probably today already see a bunch of interesting rollups that are just going to be on a 6-second latency, let alone the fact that you could still issue a centralized pre-confirmation, but it's probably still then easier to have faster force inclusion times. Maybe your centralized pre-confirmation is milliseconds, but you have a force inclusion window of 6 seconds or something that is afforded by a fast layer 1. I don't know. Like we don't have to go too much into that direction, but yeah, like how much of your base sequencing impetus is just targeted at sync composability?
I mean, to be honest, that was the main initial motivation, and it has to do with these network effects. I think for Ethereum to win, it needs to have these strong network effects, and the way that I saw things, where every single silo was isolated, was just not a winning the design. But now I'm less worried about synchronous composability, because I think if we can make the L1 a rollup, we'll have synchronous composability within the L1 at the very least, and there's no reason why Ethereum L1 has to be any less competitive than another L1 like Solana. If anything, the 1 gigagas per second vision, which is about 10,000 transactions per second, is significantly larger throughput than Solana. There's nothing special about the SVM versus the EVM. The EVM has just basically been running very, very slow historically, because we have this constraint on the validators. Thinking longer term, where we've achieved these strong network effects within the L1, then yes, it would be extremely nice to scale that to all of the L2s and to the whole internet of finance, 10 million transactions per second. But I think there's it's okay now that this takes time, as opposed to where we were previously, where we had no choice but to go through the L2 route. And for me, it's a little bit of a sigh of relief, because I can just go back to focusing on technology, as opposed to being this cat herder where there's 100 L2s and they're all going their own separate directions, and it's extremely very difficult to coordinate. Now we're in a position where, again, we can scale the scope of the base sequencer without having to do too much coordination.
Cool, nice. Before I open another bigger topic here and so on, we have in the calendar like 5 minutes left. I'm not sure if you have more time today, or if we should chop it up and do a part 2 eventually. Let me know.
I do have a little bit more time.
All right, okay. Like roughly speaking, 10-15 minutes more.
Yeah, that should be fine. Yeah.
Okay, then let's spend a bit more time. So, all right. Okay, I gotcha. So essentially, this means that you would also use based preconfirmation technology at the Ethereum L1 rollup sort of layer, right? To make it fast.
Yeah. So this brings us to an interesting subtlety, which is that for the L1, we don't have this notion of taking a subset and redefining who the sequencer is, which is something you can do at L2. And so the best that you can do at L1 is have inclusion preconfirmations at every slot. And the reason is that those who opt in, which is a subset of all of the validators, can make a promise to include a user's transaction in their slot. But they can't make any promises about the validators that come before them that might not have been opted in. But unfortunately, execution preconfirmations just fundamentally don't work in that context, because you need to have a full write lock over the L1 state in order to provide execution preconfirmations, and there's entities before you in the slots prior that can arbitrarily change the L1 state. Now, one piece of good news is that once we have APS, I expect the vast majority of execution proposers, which again are these sophisticated, rational entities that explicitly opt in, to support preconfirmations. Because if preconfirmations work very well, then there will be a significant source of revenue, similar to MEV today. So what we see today is that the vast majority of proposers have opted in to MEV Boost, and even if sometimes they don't delegate the block building to a sophisticated builder and they build blocks themselves, they do so because they choose to do so in the context of min bid, for censorship resistance reasons, as opposed to them not being connected to the MEF Boost ecosystem. So just to recap, the point I'm trying to make here is that once we move to APS, we should expect essentially all proposers to be opted in. And at that point, we can provide execution preconfirmations at every single slot, not just inclusion preconfirmations. All
right. And I guess like a sort of fundamental issue, like you said, I mean, inclusion, and that's also the realization that if listeners, if you go back to like about a year ago, I think April 2024, I did a podcast with Benedict Binz from Espresso. And in there, I was unpacking essentially, shared sequencing a bit. And what I also realized is that the early designs, they were just focused on atomic inclusion, like this inclusion guarantee that you mentioned, which I think is almost like probably the reason why shared sequencing didn't take off in a big way yet, because really what most use cases want is atomic execution. And what is atomic execution? For me, it just means you don't just get a guarantee that you included, but you also get a guarantee on the ordering of everything else that came before you. So it's not just like, hey, there's one point where you will be included, but it's like, okay, from now, this is the state. Like, this is all the transactions leading up to your conclusion. Based on this knowledge, you can now reason with certainty about state and execution of the future. That's, I think, usually what most sort of, market maker arbitrageurs would want. And then I think at some point you were especially excited about the third one, which is atomic composability, which I understood as, okay, now smart contracts can even sort of, reason about the future inclusion and ordering of transactions. And you can have smart contracts talking to each other, not just like off-chain market makers that know what the blocks will look like and they can ARB based on it. But yeah, I think we don't have to unpack atomic composability today because like you said yourself that right now your focus has shifted a bit away from that. About atomic execution, so I guess it's like you said, it's not possible to provide this for an Ethereum proposer because it's impossible to say what the state like what the transactions will be that come before. It seems to me that one of the fundamental issues is also a single like the fact that Ethereum can reorg, right? Like that you don't have single slot finality, because let's say in a simple thought experiment that every validator on Ethereum is taking the role of a centralized sequencer, giving preconfirmations for the rollups on top, right? Even then, you as a validator, you wouldn't necessarily be able to give a preconfirmation in any given slot, because you might still be on an orphan chain in the future and in your future, right? Because of the way Ethereum consensus works and the fact that you can have sort of reorgs. Would you say that's true? Like you can only have true atomic execution if you also have single slot finality, or like maybe
okay,
not?
so there's a few points that I want to kind of comment on. The first one is you mentioned arbitrages, kind of wanting these fast preconfirmations. I actually believe that preconfirmations are not appropriate for arbitrages. They're only appropriate for retail users, and the reason has to do with the arbitrager being a rational entity and the proposer also being a rational entity, and so they both want to make money from the preconfirmation, but it's a zero-sum game, right? There's some amount of MEV to be had from the arbitrage, and if the preconfirmation gives an edge to the arbitrager, it's going to mean that the proposer is losing out, and vice versa. Both the arbitrager and the proposer want to make money from the preconfirmation. So it doesn't really work. The reason why it works for users is that users are willing to pay a premium to pay for the better UX. And it doesn't have to be a lot of money, but even just a tenth of a cent is probably enough to incentivize the proposer to give out the preconfirmation, because it's a 10th of a cent that they wouldn't be making otherwise, and they're processing, millions of transactions per second or whatever it is. And so these fractions of cents really do add up. And the users, from that perspective, it's almost invisible. It's paid by the wallet, and they don't realize that they're paying a little bit more to get this better UX. Now, the other thing that you brought up was this notion of finality, and I have a couple points here. The first one is that single slot finality is, in my opinion, a bad name, and the reason is that it overhypes what it actually provides. So even if we had single slot finality, there would be instances where you don't have finality. So, for example, if the proposer in slot n publishes a block, and half the validators see it on time and the other half of the validators don't see it on time, then there's a lack of consensus on timeliness, and the attesters are going to fork into these two camps, and it's going to take time for them to converge and actually achieve finality. The other way in which single slot finality is overselling it is that the way that these finality mechanisms work is that they work over several rounds of attestations. And so today, we have one round of attestation per slot. So it takes 12 seconds for all 1 million validators to each sign the message to aggregate all of these million. Well, actually, it's not a million. It's a million divided by 32, which is about 32,000 messages. So you have 32,000 messages that are being aggregated within 12 seconds. And in order to achieve finality, you need to do at least 2 of these rounds. And the proposal that we have nowadays for finality is what we call 3-slot finality, where instead of having a big slot with multiple rounds of attestation, we pipeline the rounds of attestations with the proposing, so that the chain is kind of progressing as fast as it can, 1 block per slot, and then the finality gadget is trailing a little bit by a few slots. Now, all of this to say that actually I don't think finality is a major unlock. The reason is that most of the time you can have very, very strong guarantees on the chain by following what's called the safe head rule. So what you can do is you can look at the number of attestations that a specific block has had, and you can make 2 types of assumptions. You can make what's called an honest majority assumption. So you can assume that half of the validators that are currently online are honest. And you can also make what's called a synchrony assumption, basically saying that messages over the internet are being communicated within a specific amount of time, within a few seconds. They get gossiped around the world. And if these 2 assumptions hold, then you'll know that this block, which isn't finalized, is actually safe, in the sense that it will get finalized in the future. And really, that's what I think you should be using. And again, the finality gadget is not going to help you when it doesn't work, which is for the tip of the chain, which follows a fork choice rule, which doesn't involve finality. Now, going back to your original question, what happens if there's a reorg in the context of preconfirmation? So one important thing to clarify is that when a preconfirmation is made, it's conditional on the parent. So I only make if I'm a preconfirm, my promise is only to post a block if the parent is XYZ. If for some reason there's a reorg that changes the parent, then I'm not liable, right? Because that's that's not part of my control. So really what the wallet should be doing is, first of all, identifying what the tip of the chain is, for example, using the safe head rule, or just by looking at what has been proposed and all of the attestations. And then basically, once it's determined the head of the chain, ask for preconfirmation on top of that. And that's the best that the proposer can do. So yes, like sometimes there may be reorgs, but that's just part of life. It's something that we experience today on the R1, but the reorgs should not disincentivize the proposers from providing the preconfs. Now, one thing that will happen, or at least what I expect will happen, is that preconfirmations are going to dramatically reduce the rate of reorgs. And the reason is that the reason why we have reorgs today is, well, one of the reasons is because proposers are playing timing games. What is a timing game? It's basically where they try and use as much time as possible to propose their block so that they can have as much MEV as possible. And because they're so close to the deadline, they're playing it risky, where some of the time the attesters won't see their block on time. And so that means that half of the attesters roughly think it's on time, the other half thinks it's not on time, and so that can lead to a reorg. But if you make preconfirmations, you're incentivized to not have your block be reorged, which means that you're incentivized to not play timing games. You're incentivized to play it safe and publish it conservatively, so because otherwise you will get slashed, because you will not have honored your preconfirmations because you have a mislot. So in some weird sense, even though preconfirmations don't defend against reorg, that's just a fact of life, the incentives are going to be placed in such a way that the reorg should in practice largely disappear.
Cool. Thanks for unpacking all of that, and I will wrap it up here. I definitely need to have you on for a part 2 extension where we can go into native rollups, which was supposed to be one of the main topics, but we discussed so many interesting aspects here that we didn't quite get to it today. But we will follow up with that hopefully very soon. So let me just unpack what you just said to finish off this part 1 of the podcast. Essentially, preconfirmations, I would say it's fair to say that preconfirmations are a gadget that you will build, or the community will build, which is a gadget that rollup applications can use if they want to provide much faster UX and so on. But it doesn't come for free completely. There's some associated risks and assumptions that come with it, and roughly speaking, the calculus here is a preconfirmation is generated from what you mentioned, this sort of honest majority assumption and synchrony assumption. From there, you can build the sort of I guess the chain of blocks, and you can then associate your preconfirmation with the parent and sort of give that preconfirmation. And as long as there is first of all, if there is a reorg, then the application still has to deal with that, and that might be a bit of a sort of there has to be a graceful sort of handling of reorgs. If you go in fast mode, right? If you go in preconfirmation mode on the application, or the other thing that could happen is not a reorg, but essentially where the preconfirm is actually not keeping their word. And this would usually happen if somehow the extra fees that the preconfirm makes from including preconfirmations transactions, which are probably paying more fees, like you said, than normal transactions, and the MEV that they can extract from not actually sticking to honoring that preconfirmation that somehow adds up so that they net probably make significantly more, or a bit more at this point. At that point, they wouldn't honor it, which again is something that the application, I guess this can be handled at the actual application layer, where it's like, hey, maybe I'm building a sort of DEX interface on this rollup thing, and on this rollup, I as the DEX interface, the wallet, whatever, I'm allowing my users to go in fast mode if they agree the terms and conditions to that, or if they, I don't know, if they have less than $1 million or whatnot, like whatever the collateral is and so on, in flight at that moment. And if you want to do bigger trades or something, you can't access this fast mode, for example, like stuff that can be solved at the application layer to essentially handle the risk that is still there in preconfirmations. Is that sort of a fair summary?
Yeah, I think you're right that preconfirmations are not a silver bullet. There's a lot of caveats. One of them is that they don't solve the MEV problem. Another one is that they, in exceptional circumstances, they can be reneged. Actually, one thing to mention here is that the preconfers can have arbitrary amounts of collateral. So if they want to go and deposit 1,000 ETH of collateral, they have the freedom to do so. And I guess it's a bit of a trade-off, because they're locking 1,000 ETH, so they have to pay the cost of capital on that locked ETH, but they can provide more preconfirmations to like maybe large traders or whatever it is. Fundamentally, you should think of preconfirmations as being something that is like strictly weaker than inclusion, and inclusion being strictly weaker than finality. And there's actually a whole spectrum in between, right? Like there's inclusion with some amount of attestations, and that's a spectrum. And even like before inclusion, there's a transaction that has been gossiped and signed by the proposer. And basically all that we're doing is that we're extending the spectrum on the very low latency side of things. But yes, like fundamentally, inclusions can be reorged, and so preconfirmations will, because they're strictly weaker than inclusions, they can also be reorged. But despite this very long list of caveats, I still hope that for the vast majority of use cases, like 99% of the time, 99% of users and applications, preconfirmations will prove to be valuable.
Yeah, and ultimately it's all about an open market and so on, right? So if you have that technology available to you and you want to build a very sort of fast yet decentralized roll-up DEX, and you're building an interface on that DEX, like it's completely up to you to absorb and deal with that risk for your users, right? And like I said, you could like have terms and conditions. You could have an insurance policy to deal with such edge cases. And I think what you said then is also another contributing, like a good factor is like MEV seems to be one of the main issues, because MEV is associated with the likelihood of the preconfer defecting from the preconfirmations. And like you said, like if you build an application specific sequencing rule or something, like some way like of not having so much MEV on the table to begin with, then the collateral margin probably also like is has to be less and so on. So if you reduce MEV, you can also reduce collateral required, and you reduce entropy maybe in a way for that base preconfirmation. And yeah, I guess reorgs, like you said, can also become less with more like APS technology and so on. I think is what you mentioned there. Attester-Proposer Separation. And now actually, sorry, you mentioned preconfirmations themselves fueling less reorgs because you're now more incentivized to propagate the block quickly. I think that was it.
Yeah, exactly. Your incentive. So there's two types of failures for preconfirmations. There's what we call safety failures and liveness failures. A safety failure is when you made a promise to include a transaction, for example, at position 12, and you just don't do that. You include it at position 3 or 30. So that is something that is what's called an attributable fault. So you know for sure that the preconfer cheated, because you have these cryptographically signed messages that prove that they cheated. But then there's this more subtle form of fault, which is the liveness fault, where they made a promise, but there just was no block. It was an empty slot. And here we do need to slash as well. And today, without preconfirmations, if you miss a slot, it's not a big deal. Like you lose, you have a very, very small penalty. But if you stand to lose a whole ETH because you miss your slot, you're going to be damn sure that you're going to make sure that you have very, very high uptime, and that you're going to propose your blocks soon enough. So basically, if you opt into the game of preconfirmations, you need to make sure that if you make preconfirmations for the first, let's say, 11.9 seconds of a slot, you're going to be online for the last 0.1 second of the slot. Because if you go offline halfway through the slot, then you're going to get slashed. And today there's this game called timing games, whereby you try and artificially extend the size of your slot, but that is a very risky game to play in the context of preconfirmations.
Gotcha. Yeah, and the reason why it's even more critical is to honor preconfirmations is because the applications, like, they already live in this hypothetical future of the preconfirmations, and there might also be composability between them, or or why would you just in a nutshell say why it's even like why missing a why not honoring a preconfirmation is even worse and should require a higher penalty to be paid, is because it's almost like reverting finality, I suppose. I mean, I know preconfirmations aren't finality, but nowadays, if you go to Ethereum itself and you don't wait for the confirmations, that's on you. That's not Ethereum's fault, right? Like, sure, maybe the proposer gets a little bit of a slashing penalty if they weren't live, but the application hasn't been updated, right? The whole point with the pre-confirmation is the application should be able to update, right? Like that's like a sort of social contract almost. So that's why the penalty should be more severe. Is that sort of philosophically the reason? Or?
So the reason is actually there's an attack, which is that, let's say a proposer controls 2 slots in a row, and they make preconfirmations for the first slot, and now they want to renege and basically capture arbitrage that they promised they wouldn't capture. Well, what they can do is that they can be offline and not propose a slot not propose a block in the first slot, and then in the second slot just capture all of the arbitrage. So it's just to defend against this. It's mostly to defend against this attack, but also to, as you said, to disincentivize against the bad UX that you're inflicting on users, because they're expecting their trade to go through at a certain price, and now it's just not going through at that price.
Yes, I guess the simple way of looking at it is like, okay, if like on the L1, if you're not live as a validator, sure, you violated your liveness agreement, but at least you didn't issue any confirmations during that time that were erroneous, right? Versus here, you've already given a confirmation and now you don't honor it. It's almost like an equivocation, like of sorts, I guess. But yeah.
Exactly. Yes. Yep.
Yeah. So it should come with the highest penalty. We'll cut it here, and we didn't touch native rollups. We just published an article. Everybody go to the gelato.cloud/blog. You can read about native rollups there. We published that recently. Really great guide to get you up to speed with the topic. You can read about ZK there. We did an article, especially like with focus on succinct and risk zero, and yeah, much more on there. Interop, we have a great series on there about bridging, L2s, rollups, sovereign rollups, all of that stuff you can find there. So yeah, thanks a lot, Justin, and excited to continue that and finalize it with a discussion about native rollups next time. Thanks a lot, and thanks for going overtime as well. See you soon.
Absolutely. Thanks for having me.